Okay, renewable energy policies are developing rapidly around the world. Developing and developed countries allocate investment for the application of renewable energy due to a world agreement to involve all countries in reducing greenhouse gas emissions. The development of biomass use in energy production is estimated to grow 6% between 2021 and 2030. Hi, hello, my name is Ayn Akmal, and here with my lecturer, Pak Yusran and Prof. Ansar are the author of this paper, and I'd like to deliver our research paper under the title of Techno-Economic Evaluation of Co-firing Method with Circulating Fluids Bed Boiler Type in Indonesia on the certain Engineering International Conference today. Ladies and gentlemen, this is our outline. There are four chapters on our presentation. There are introduction, method, result and discussion, and conclusion. In introduction to co-firing, efficiency and emission analysis, economic implication and future prospects. In method, in method chapter, there are analyzing the test results of co-firing in two circulating fluids bed power plants in Indonesia, and we're discussing the impact of co-firing on energy efficiency, emissions, and the economic implication for the power plants. In the result and discussion chapter, we exploring the importance of selecting the optimal biomass composition for co-firing to ensure technical and economic feasibility, and we providing insights into full selection and the implementation of co-firing methods based on the study's findings and their implication for power plant operations. And in the next chapter, our conclusion, we are projecting the growth of co-firing and biomass consumption in power plants between 2021 and 2030, based on industry forecast and government targets. And we outlining strategies for the effective implementation of co-firing methods in power plants, considering both technical and economic factors. In the next slide, our introduction. The development of biomass used in energy production is estimated to grow 6% between 2021 and 2030. The Indonesian government is targeting the availability of co-firing power plant with total capacity of around 18,000 megawatt and biomass consumption of 9 million tons per year by 2025. Renewable energy policies, the global shift towards renewable energy sources, and the significance of co-firing in reducing greenhouse gas emission. Next, Indonesia government's target for co-firing power plants and biomass consumption by 2025, emphasizing the country's commitment to sustainable energy solution. And then challenges and opportunities, exploring the challenges and opportunities associated with integrating biomass into coal firing methods. Uh, in this slide, this research analyzes the results of applying co-firing to two plants. There are plant A and plant B, with the type circulating fluid bed boilers in Indonesia in 2022. The research the research reviews the efficiency of energy produced, exhaust emissions, and financing. The fuel used is lignite coal, while the biomass is sawdust and wood chip. And the next slides are method. The first is energy efficiency. The energy efficiency is measured by calculating the value of delta, which compares the difference in boiler performance between co-firing and coal firing, divided by the boiler performance during co-firing. After that, there are exhaust gas efficiency. The efficiency of greenhouse gas emissions is measured by differentiating the emission values when burning pure coal and with co-firing. And the last is economic efficiency. Economic efficiency is achieved by differentiating the cost value when burning pure coal and burning with co-firing. And this slide is high heating failure. Boiler performance is seen the parameter high heating value of the calorific value produced by the fuel, which is calculated in units of kilocalorie per kilogram, or how many calories are produced when 1 kilogram of fuel is burned. Efficiency analysis of the high heating value parameters produce comparative values between biomass and coal co-firing. The delta high heating value in figure 1 shows a negative number, or the heat value produced in co-firing is lower than in coal firing. Of the four treatment or the of the four treatment, it was found that the best level of efficiency for the high heating value it was parameter was a value close to zero. If delta high heating value equals zero, the heat value produced in co-firing and coal firing is the same. Researchers found that ASD1 treatment showed the best effectiveness of the use of 1% sawdust and 99% coal produced on efficiency level of min 0.135%, using 3% sawdust and 97% coal produced high heating fuel comparison value of min 0.004%. Meanwhile, Plan B with a 5% sawdust and 5% chip configuration has high heating fuel compression values of min 0.0054%. And the next is full fuel consumption. An efficiency analysis of fuel consumption parameters compares fuel consumption values between co-firing biomass and coal. The delta fuel consumption values in figure 2 shows a positive number at plan A and a negative at plan B. It can be concluded that fuel consumption is more efficient at plan A, especially when using 3% sawdust. Researchers found that SD2 treatment showed the best effectiveness of the use of 3% sawdust and 97% coal, resulting in an efficiency level of 60.62% using 1% sawdust and 99% coal produced, and full consumption ratio of 50